Good afternoon, everyone. Welcome to the webinar, the Floating Solar Plant Mooring Challenge. Glad you are joining us. My name is Christian. I'm a project manager at Solarplaza, and with me is my colleague Tom as well. And I'm very glad to see that an incredible amount of industry professionals are joining us this afternoon. I see that we already have over 200 people joining us live, and probably quite some will join still. So that is good to see. And today we are, of course, going to talk about the floating solar PV market. Yeah, and that you can see here on the next slide. And more specifically, we're going to talk about mooring design challenges. And this is our webinar program of today. We're going to cover topics such as different mooring design solutions, common challenges, offshore mooring specifics, but also about improving reliability, numerical modeling challenges, innovative mooring solutions, and many more topics. So I'm looking very much forward to a good discussion today. And this webinar is, of course, in anticipation of the virtual floating solar conference, which you can see here on the next slide, if everything works correctly. Well, it's still lagging, but I can explain a bit more in the meantime. Oh yeah, there it is. So the webinar is in anticipation of the virtual floating solar conference, which will be running on 3 and 4 November. And we have a great lineup of speakers ready, which you can check out on the website. And we are currently finalizing the program, adding some more exciting speakers. So make sure to keep an eye on the website in the coming weeks. We also are publishing an overview of attendees. We are having tickets being registered every day, so we're adding those companies on the website as well, so you have a good view on who will be joining us on the virtual event platform in November. And yeah, we are going to navigate all the opportunities and challenges related to floating solar in the event, with over 200 decision makers, industry professionals from basically all the relevant stakeholders involved in the industry. And we will be learning everything about floating solar, about the subtopics like the environment, efficiency, O&M challenges, different system solutions, but also new frontiers, hydro hybrids, nearshore, offshore, floating PV. So yeah, it's looking to be a very exciting event in November. And exclusively for webinar attendees, we have a promotion running from yesterday until tomorrow. So it's running until tomorrow evening, and especially for webinar attendees, you can register for the virtual conference with a €100 discount. And for that, you can use the following promotion code, which is here on the slide. We will also send it to you after the webinar, and tickets can be purchased through the following link or the registration page if you go to the website. So make sure to use this offer if you're planning to join us in November. And before we dive into it today, I would like to briefly introduce Solarplaza to you for the people who don't know us yet. Our mission is to positively impact the world by accelerating the sustainable energy transition. And we've been doing that since 2004 through our events, through our trade missions, but also through our news portal. And we have organized already over 140 events in over 40 countries, but lately also a lot of virtual events on our dedicated platform that we have developed. Yeah, and we help professionals become more effective in their business development by providing these unique networking opportunities, but also high-level content and knowledge sharing. For today, some final practical notes. If you have any technical issues, please let us know through the chat box. If you have questions for the Q&A, please ask those in the questions box. We will have a Q&A session at the end, as you saw in the agenda. So I would like to encourage you to send in questions during the presentation we will have in a bit, and then we will cover all your questions, or as many as possible, at the end. And also the presentation slides will be available afterwards, as well as the recordings of this webinar, which we will send to you probably tomorrow by email, but also publish on our YouTube channel. Now, and to dive into the topic of today, we would like to start off with poll questions, get a little bit of feel of the audience today, but also your familiarity with the topic. So I would like to involve you and create some interaction here. Please bring out your votes in the first question. How familiar are you with the topic of mooring design? Either very familiar, somewhat familiar, or yeah, you don't know much about the topic yet. So we will gather some responses now. I see many votes coming in already. So let's close the poll and put the results on the screen. So we can see that the majority of the audience is already somewhat familiar, and a part of the audience is really new to the topic. And there are also some experts among us who are very familiar with mooring already. And then I would like to go to another poll question, which is the following. Did you already commission or participate in the commissioning of a floating solar PV project? Let's see how many of the people joining us today have experience already with rolling out projects, either as a developer or by being part of project as another stakeholder. The votes are coming in, so we will publish those as well. Okay, and that's nice to see. We have a lot of people who are relatively new to the industry, just starting with floating PV. Yeah, the big majority has not yet developed a project before. So with that background knowledge, I would like to proceed and introduce the speakers of today that will be sharing more info with us. And the first speaker is Pierre-André from Ciel Terre. He is an R&D anchoring engineer, and he has over 6 years of experience in the offshore industry, was in his previous jobs mainly concerned with dynamic positioning, and is now at Ciel Terre involved in the floating structure behaviors and anchoring issues. So please, Pierre-André, join us. You can enable your camera and your audio as well. And the second speaker of today is Felix. Let's see if I can get his slide up as well. And Felix is the head of floating solar at INNOSEA, and he's an offshore renewable engineer, has over 10 years of experience already in offshore renewables and solar, and is responsible for techno-economic analysis, cost modeling, and strategy advisory services. And he leads the floating team at INNOSEA, which has already developed 900 megawatt of projects to date. So welcome, gentlemen. Thank you for joining us. And I would say let's proceed with your presentation. And once again, for all the attendees, please type your questions during the presentation, and we will cover those at the end in the Q&A. So we will now give you the controls. So please go ahead, and you can start with the presentation. And I think we still have to unmute.
Yeah, it's okay. I think
now it should be working.
Okay. Okay. Thank you, Christian. Yeah. So first of all, I would like to thank Solarplaza and all the team from Solarplaza for organizing this webinar. I also would like to thank Felix and INNOSEA for sharing with us this session. And last but not least, let me thank you, all of you from the audience, for having responded in numbers to this invitation. That is a great pleasure and honor for me to share with you our feedback on this subject.
So yeah, good afternoon all. So my team and I were delighted to brainstorm and notify new mooring configurations to boost the floating solar sector reliability and cost efficiency. So along with Ciel Terre, so it will be a pleasure to share some of the lessons learned from our first project design and deployment.
Okay, so sorry, there is a bit of lag. Yeah, it's okay. So I will not go deep into details for the agenda. You can see, and Christian just introduced it before. So let's start with a brief introduction of our boss company. So what is Ciel Terre? So at the very beginning, Ciel Terre was started by providing roof PV systems in 2006, but driven by our innovative DNA, we have developed our floating technology, Hydrolio. We dedicate all of our efforts to floating solar market since 2011. We act for the energy transition with the highest number of floating PV projects around the globe. It's around 2,000 projects in 30 different countries in 2020. Ciel Terre is no longer a startup, but we are a worldwide company with 170 collaborators around the world. We have 13 local offices, 40 manufacturing lines, 15 agents and distributors. And we think that having this worldwide presence allows us to understand the market needs. And this enables our R&D team to focus on optimization, development of new products to be adapted to the market specifications. After 10 years in FPV, we faced some issue, but this is how innovation grows, and sorry. So we have learned a lot and found solutions, and I'm here today also to introduce the learnings and the feedback from this all this experience.
And so on our side, so INNOSEA, we're part of a larger group which is called LOC, London Offshore Consultant. It's actually a 40-year-old company, combining on one side operational construction experts, and on the other side engineering specialists. So we are 400 people worldwide. We have a focus on 3 specific sectors. So first, the shipping sector, the oil and gas sector, and the renewable sector. So in particular, offshore wind and floating solar, notably. So LOC Group is the world leader in marine warranty surveying. So basically ensuring that every single offshore project is constructed in a safe and cost-efficient manner. So INNOSEA is one of the engineering company within the group, supporting both IPPs and EPC on offshore wind and floating solar projects. So we are service providers focused on design, costing, and R&D development. We've worked until now on, so we've been involved in the floating solar business since 2017. So as you understand, we're more coming from the floating business rather than from the solar business in itself. So our first project was in France with the Omega 1 project from Accio. And since then, we worked on around 45 projects worldwide, biggest project being in Asia with over 100 megawatt peak, and the rest in Europe and on island. So we've had a chance to work with various, let's say, floater technologies. So INNOSEA, we are technology agnostic ourselves, and we have a strong focus on R&D. So in particular on innovative mooring configurations. So this way we were very glad to start this collaboration with Ciel Terre some years ago to identify, let's say, new solutions for floating solar specific mooring challenge.
Now, Felix, let's stop extolling the merits of our companies and let's be transparent with the audience on the challenge we face. Before that, just a quick clarification. During the presentation, you will hear about anchoring and mooring terms. Anchoring term is more about everything at the very start of the mooring line, away from the floating platform, and mooring term is more about the mooring line itself from the anchor to the floating platform. But when this is not specified, actually, anchoring or mooring is a global term to speak about the whole system maintaining the FPV. So let us remind the purpose of anchoring floating solar plants. Why do we anchor? We anchor to prevent the solar island to be blown away by the wind, the wave, and the water flow. We anchor to prevent the movement of the solar island, or at least minimize this movement. We anchor to prevent the solar island to hit the banks when water level is changing. And to give you a rough idea, we have at average 30 lines per megawatt. I don't know, Felix, if you have an input to share about the number of mooring lines in other industries.
Yeah, typically. So this is the floating solar market is actually quite specific on the mooring, in particular the mooring challenge, because offshore, where if we talk about a boat or an FPS, a floating platform, typically, or either an offshore wind, so turbine, floating turbine, you'll have, let's say, one big platform and then around dozens of mooring lines. On floating solar, instead of having one float, you have 10,000 of floats or even more, and hundreds of mooring lines. So the tension within the lines drops from, let's say, 100 tons per line to down to 1 ton typically. And there's a lot. This is a strong challenge because, numerically speaking, it's very difficult to actually model how the whole island behaves very accurately. So we need to identify. So there's a numerical modeling challenge, and we need to identify, let's say, innovative approach to actually accurately model those plants. So this is very interesting in terms of engineering, but quite challenging in terms of solutions.
I saw a lot of you know about mooring and anchoring, but just to let you know, anchoring scope can be splitted into two different categories. You have the bottom anchoring and the bank anchoring. And on the same project, on the same plant, you can have both. This is just a clarification for the next challenge you will see.
Yeah, exactly. And basically the type of anchors depends on the soil conditions. So on some soil conditions, typically with very steep slopes, dead weight can be unsuitable. And other type of anchors exist for specific application. For instance, if you look at the dam project, where there's a lot of sedimentation, the soil can be quite muddy, and you need to find alternative solutions, such as suction anchors, for instance, on those type of location. And but more generally, the most standard solution would be, let's say, helix or plate anchors, which would be installed on leg banks for cost-efficient anchoring.
So here in floating solar, we face some challenging water body types, very different from a project to another. And here are some examples that we have managed in the past few years. So you have, for instance, Altora Bagao Dam, which is a dam lake in the north of Portugal. It is a 50-meter deep at anchoring points. And the challenge for this project was the fetch and the wind, that are quite big, and the 30 water depth variation. I don't know, Felix, if you have ever experienced such water level variation.
Yeah, so that's very, let's say, peculiar, because offshore we only see up to, let's say, 17-meter maximum water depth variation. So that's a new challenge typically for floating solar. And then we need to, let's say, adapt some of the solutions that we know that are, let's say, well functioning for the offshore market to the floating solar specific market. So yeah, we need to adapt to it.
And we also had another project in China, a new CSEP, which is a very large project with a very large surface coverage. And the challenge for this project was of course the number of anchors to be deployed. Another different project was in Germany, a Mewald project, for which actually it was impossible to moor at the bottom of the lake, and for which the island was very far away from the shore and the banks. So for this project, we managed, thanks to an optimum innovative mooring configuration, to only deploy 11 anchors.
So the idea is to bridge, basically, to bridge the very high depths. So with innovative mooring configurations.
Yeah, exactly. And we think this is a very great opportunity to have such different projects because the feedback you get push you to innovate. So several issues linked to the anchoring may occur on site. We had accidents at Ciel Terre, that is not a secret, but we have learned from these experiences. And below are the main issue we have identified and that we want to share with you. You can, for instance, have the domino effect. We call it the domino effect, but you can find a lot of definition. But basically, this is when you have several lines, and if one breaks, the loss of load's capacity is passed on consecutive lines, and then can be overloaded.
Yeah. So typically, that's similar to what we see in offshore with the design load cases, which is called accidental limit state, where we actually need to verify the robustness of the mooring design, let's say identify the consequences when one of the most critical lines is actually missing due to some incident. So and this let's say accidental limit state is something that needs to be applied to floating solar from our perspective, from a design point of view.
Yeah. Another issue can be the anchor misplacement. Actually, this is when you consider a specific position of your anchor when you do the design. But when you are in operation doing the project, in reality, you install the anchor, and especially when it is at bottom, you have a misplacement, you have an installation tolerance. So then the tension in line is not as expected. And to deal with this issue, we include safety factor in our design, for instance, but another solution could be to reduce these tolerances.
Yeah. So there are several ways to do that, notably using GPS positioning for each one of the anchors. And after the first design and the installation campaign of the anchors, we can redo a design, so verify the design and provide it's a as-built design configuration to verify its suitability and adjust the length of each one of the lines. So
we also experience the specific shape of the plant that can lead to concentration of load at critical locations, leading to sorry, go Felix.
Yeah, no, the challenge here is very interesting. Basically, the island is a bit flexible, so it leads under wind loads. It leads to irregular shapes, and those shapes will lead to non-homogeneous loads between the mooring lines, and basically it becomes quite challenging to actually estimate those loads. So we're not able to do, let's say, any static Excel calculation anymore. We need to do numerical modeling to be able to better understand the non-homogeneity between the tension of the lines, and obviously this tension might lead to an anchor failure. So this is why we need to focus on that matter in particular.
Yeah, exactly. We focus on that matter, and we also have design rules in place to limit the use of this kind of shape, leading to critical distribution of load in lines. And another issue could be also the offset generated by water level variation. Actually, that makes your mooring lines slacked at lowest water level, and this can lead to abrasion on seabed because the line will touch the seabed, and you can also have clash with other structure due to the high offset you have in the plant. The solution for this is to use flexible mooring, and the flexibility you can obtain can be either by the material, such elastomer, or you can also have a specific mooring configuration that ensure you at lowest water level you still have tension in the line, so that you do not have this offset. So basically, anchoring challenge is to manage to deal with all these issues, providing a safe and cost-effective way to anchor the solar floating farm. And this is on what we are working on internally and with INNOSEA. And we are sharing this experience to participate improving the anchoring system on the market. So all these challenges need to be accounted for in the design and in the way we model the system. They also need to be correlated with the reality. So mooring system is mostly designed by the environmental loads. Determining them is a key step in the anchoring design because underestimating them can lead to accidents, whereas overestimating them makes the company not competitive. So they are from 3 different sources. You have the wind. Wind loads are the predominant ones acting on the solar farm. For the wind estimation, we use a CFD calculation, which are correlated with the wind tunnel test. And we consider in our design wind as the static loads in our design process. You also have the current. For the current, we have done pooling tests so that we can get the friction factor of the global array. And basically, this is the same kind of formula which are used for the estimation of effort from wind and current. Only the density of the free discharge, of course, and coefficient used are different. And for wind, they are far well more complicated. What also need to be considered are the waves. But the first step for the wave is to have an accurate model of the sea state to get the wave properties. This can be done using formulae relating fetch and wind speed. And for Ciel Terre, the estimation of wave loads is based on the empirical formulae to get the average drift load. For the time being, dynamics of wave have been more an issue in terms of fatigue for other elements in farm. And for fatigue assessment, we need to get occurrences of each sea state event.
Yeah, and so more generally, we need to consider that the wind load. So for most of the application, typically on a quarry lake, the wave, let's say the wave load will be let's say rather insignificant in comparison with the wind load. So for a typical quarry lake site.
So in addition to the environmental loads that are the main input actually for the mooring design, Ciel Terre is also relying on its physical tests to provide design rules that need to be considered for the mooring system design. We can do many different tests on the different configuration, on the different mooring material, on the configuration, on the anchor type and capacity. Actually, this allows us to validate our design at a real scale before it comes to operation. I think we are lucky that solar plants have a reasonable dimensions so that it can be tested at real scale.
And that's the real plus. So as a floater designer, having the opportunity to actually test at let's say real scale and full scale your system is a real plus. So this is very useful also to test the innovative mooring design that you've been developing.
Yes, yes. Now let's talk about the numerical modeling challenge we have. As Feli said, actually, it's a bit complicated to model it numerically because once the environmental loads acting on the solar farm are well estimated and the design rules are compiled, the next key step is to model the whole interaction between the plant and the mooring system. And the way to model it must be quick, efficient, and safe. So for us, this is a challenge as the farm are made with multiple bodies, and numerically, this is not feasible to model each of the float. This leads to convergence issues and unrealistic CPU time. We use internal analytic tool to design the mooring system safely, and we also do some numerical simulation for complex and specific cases. So just typically, we solve the catenary problem and we do a quasi-static analysis. We also know that the stiffness, of the plant have an impact in the design of the mooring system. And thanks to our physical tests, we can consider it in our design and elaborate design rules. We correlate numerical model with physical tests to reduce the number of tests. I mean physical tests which are quite time consuming.
Okay, so now it will be interesting also to see if we can learn from other offshore sectors. So this is what I want to bring the next slide. So typically, from our point of view, one of the key points from the, let's say, as common challenge in offshore mooring is first to confirm the robustness of the mooring, and this is done through the AARS, so accidental limit state approach. So this is one of the cases that we need to run when designing a platform, so a floating solar farm. We've seen also, so we've learned from other sectors that there's a strong, let's say, installation challenge. So most of the time, you need to focus about what type of soil is available, so what type of soil is there to actually select your anchor, also what kind of marine spread could be available on site to actually deploy those anchors. And on top of that, something that we've learned offshore and that we've seen already in the first few floating solar projects, you need to take into account the temporary anchoring management. So you won't be able to build your plant in one day. So at some point, let's say strong wind conditions could occur during the construction and without all the mooring lines in place. So you need to find a way to deal with that and ensure that you won't have any risk, let's say operational risk during the construction. That's key because that already happened in a couple of projects. So it's a real point of focus. As it was described earlier as well. You always have operational discrepancies between, let's say, design and as-built configuration. So splitting the anchoring campaign and the mooring campaign itself is very important to allow to adjust the design, adjust the length of the mooring line. So this is something that's very critical. Something that has been, let's say, that's been learned in offshore. In particular in offshore wind, is the use of, let's say, marine wind survey. So this is something that might be dragged to the floating solar sector for, let's say, large sites, over 50 megawatt sites typically, where, let's say, expert insurance witness can confirm on site that the construction is handled properly. And the last point is that we can learn from other sectors for the mooring configuration in itself. So typically, if you look at on the right, an aquaculture farm, there's, let's say, alternative way to moor actually, let's say, islands. So that's also interesting to have a look at that. Another topic, for instance, in the shipping industry is to lower the size of the anchors to limit, let's say, the soil impact. So it's good to see what has been developed in other industries as well.
Okay, so now let's talk about the lessons learned and to introduce also the new anchoring solutions. So here, so here are some feedback we can share from the different projects we have made. On-site wind data, is necessary to enable the fatigue design, but this is something that we do not systematically have. For that, we need to assume conservative assumption, which can be frustrating. But yeah, this is something we are being faced with several times. The lack of wind data on site.
So it's not a wind farm design, but we still need the wind data is very critical, as you understand, for the mooring design itself. So this is why it's critical. And basically, we can either use standard data, which will be the less qualitative data, on-site data, or satellite data.
Yes, that's true. Thank you, Felix, for the intervention. And we have also been faced with the fiber rope degradation. which leads to strength capacity decrease, and this needs to be considered into the design. For instance, for this issue, we have made sample campaigns to have real scale curve degradation on site condition, because we think this is the best feedback to understand the behavior of the project.
Yeah, another topic will be on the, let's say, site-specific challenge. So obviously, the site condition will lead to, let's say, site condition or permitting conditions. Typically, if you're not able or allowed to anchor on the banks, then you need to anchor subsea, and you need to investigate how you can do that in the locations. Typically, on dam lake, we have a lot of space most of the time, but on quarry lakes, it can be quite challenging. So we need to have, let's say, detailed bathymetry surveys typically to update the initial design.
Yes, and sorry, Felix.
No, exactly.
Yeah, I just wanted to see, also had the issue we have on soil conditions, because soil conditions can definitely drive the anchoring solution you choose. For instance, if you have steep slope, you can discard the dead weight anchor solution. If you have cohesive soil, cohesive soil actually will enable the use of plate or screw anchors. So it's a bit tricky to, before doing some investigation on site, before knowing the soil condition, to choose the anchor.
One other topic that we've seen in particular on dam reservoirs or irrigation reservoirs is that those reservoirs could be fully emptied, and then you have a stranding challenge. So basically, the island will go down to the ground, and partial grounding could lead to specific issues like compression, and even uneven ground could lead to the break of some of the connection between the floats. So this is one of the challenge in irrigation reservoir. Another thing that we've seen is actually the first project on which we've worked together, Ciel Terre and INNOSEA, is a project in salty water with heavy metal pollution, and there was a strong corrosion challenge for each one of the components, in particular the module support, where we needed as soon as possible to deploy samples to better understand the corrosion, let's say, speed rate, so that we can enable, let's say, a safe design over 20, 25, 30 years for the project.
Another thing we have experienced also is we have seen twist in the mooring line during the deployment of the mooring line themselves, because you install one day, you leave it during the night, and the day after you come back, you just pull on the line, you connect, and if you do not do any rough survey, you have you can have a twist in your lines.
Yeah, exactly. So you need to find a way to actually let's say, handle your lines between the anchoring campaigns and the installation campaign. So this can be quite critical, because if you don't have a let's say, divers or ROV, so you are not able to actually detect this incident. Another challenge, obviously, the temporary mooring line management challenge that I already mentioned. The accuracy of the anchor positioning as well, and the uniformity of the line tensioning is something that's very critical, and that we already touched upon. So those are very common deployment pitfalls that we need to avoid. But there are, let's say, other couple of lessons learned that we wanted to share, notably regarding to let's say the space that you have for the floater assembly. So Pierre-André, I think Ciel Terre has worked on many projects with let's say strong limitations.
Yes, and we needed to build up some pontons just to face with a slope on the banks, for instance.
Mm-hmm. So water level variation can be another problem, another issue. So for instance, on the dam lake, we've seen that configuration where due to the water level variation, there's a strong, let's say, a huge difference, a strong height between the assembly, let's say, slope and the actual water level. So this leads to, let's say, some kind of downtime during the construction phase.
Yes, we have also been faced with fatigue within support module and mooring components due to wind-induced wave or also boat generated waves, which is very hard to anticipate because you need a lot of data from the boat to get the wave induced by the boat. So it's a bit a tricky one.
Mm-hmm. And yeah, more generally, now we are focusing about reducing the capex of floating solar, but we should bear in mind that the OPEX will be one of the major challenges in 5 to 10 years. So there's a trade-off that we need to find in terms of, let's say, overall project cost optimization between the capex and the OPEX. So limiting the number of anchors is one objective, but we should bear that in mind.
Okay, so to deal with all these issues we have met, this is the kind of technical specification we impose ourselves for the future anchoring solution. We try to improve the solution based on the experience we have. So we try to avoid domino effect, we try to withstand the installation tolerances, etc. This is the kind of specification we impose ourselves.
Exactly. So we've developed, let's say, solutions to actually, let's say, cope with those specifications.
Yeah, so as a conclusion, so as a pioneer in FPV, we have experienced many different projects and issues. This experience allows us to improve our anchoring solutions. This is also, we think, our responsibility to share our knowledge, to make the market safer, providing our best feedback. We also hope that other actors in the industry are ready to do the same, as we are sure we have a lot to learn from them and from everybody. And this feedback is our first stone we bring to the collaborative effort to make the market safer. And we have also understood that as the market is growing, partnership is one of the key to maintain the technical quality at its best level.
Yeah, exactly. So this is why we are all pushing and sharing the first insight to, let's say, move towards a more standard engineering approach, also a design approach. This is why Ciel Terre and INNOSEA are both part of the GNVGL floating solar JIP to actually deliver the first recommended practice on floating solar that will be issued, let's say, in March 2021. So we're happy to let's say, yeah, make this market a bit safer and then more reliable. So happy to share some more, let's say, some more information and let's open the floor to questions.
Yeah, and that may be the best transition I can have. I'm not as good as Netflix for teasing, but Olivier Philippa, Hydrelo Director, will introduce other lessons learned during the Floating Solar Conference on the 3rd of November. So do not forget to book your entry for the digital event.
Well, thank you, gentlemen, for the presentations. Very interesting to learn more about all the components of mooring. And in the meantime, we have received a lot of questions already. So I think the presentation was very clear, but still there are a lot of questions. So I suggest we proceed right away with the Q&A. And the first question I see here that I would like to ask is, how do the mooring requirements and design processes change when you move into more offshore / open sea locations? Maybe it's only possible to say something about that, like in general, but can you share some thoughts on the difference there?
Yeah. So yeah, we've been involved on some, let's say, technology developments on offshore. So we have some clue, and there's, let's say, different paradigm. One of the key challenge for offshore floating solar technologies will be mostly the connections between the floats. So obviously, in terms of site, we'll have on top of the, let's say, the strong winds that we can have, we'll have waves and quite significant waves. So some technology are aiming at 2, 4, 6 meter HS, so very strong waves. And they need to cope with that. The connection will be one of the key challenge. Something that's also a lot more critical is the installation process, because then you need to wait for the, let's say, proper timing to actually install your system. So additional the weather downtime and let's say legs of construction. So yeah, those are, let's say, one of the few challenges that we see offshore. And yeah, we are quite excited to see what will happen with the first, let's say, megawatt scale deployment.
Yes, and if I can add also, I think one of the big challenge we will get when we come to offshore is the wave and the modelization, because as floating solar plants have very small draft regarding the draft we can have on a offshore platform. The way we model it is very different. For instance, when we do some fatigue calculation, we use a simple Morrison formulation, but when it comes to big Earth wave and the biggest dynamic impact, you need to have a proper simulation, and this is quite challenging, I think, for the next years.
Okay, thanks for answering that question. Another participant is wondering, because you shared a bit, of course, about different examples of projects in different locations, and also the required number of mooring lines, depending on the type of mooring you choose, but also the depth. But someone is wondering, this probably depends a lot on which solution you are using for your floating design, right? Is this like a general rule that applies for like the systems that Ciel Terre is using, or can it differ a lot for other kind of systems as well?
Yes, I would say it definitely depends on the technology of the floats, because you can have many different technologies. But what I would say is you have to find a compromise between the number of anchors you want to use, because of course, if you want to decrease the number of the mooring lines, you need to improve the capacity of the anchors you use, and you also need to have a specific anchoring point, the connection point, which can become weak points on the farm. So yes, it definitely, I totally agree with the question. It depends on the technology you use, but it's always a story of compromise, because if you choose another technology, you will have another effect. Let's say you can have a more dynamic impact due to waves, because the wavelengths will excite your structure. So yes, it's always a story of finding the good compromise.
Yeah, that makes a lot of sense, of course. And also following up, so in the previous question, you already touched upon that, Felix, that like, of course, the process of installation changes when you go offshore at higher depth of the area. Someone is asking, how do you stay in the tolerance area for anchoring at over 50 meters depth? What kind of equipment is used for that in the installation? So
obviously, it depends on the technology that we deploy. But let's say if we deploy, let's say, a plate anchor or an helicoidal anchor, so we'll, let's say, have some kind of box, let's say, to just deploy up to that should be deployed up to the bottom, and with pneumatic or hydraulic, we can drive, let's say, this anchor through the soil. So obviously, at 50 meters water depth, we'll have a strong accuracy challenge in terms of positioning. Typically, we'll be probably closer to 0.5 to 1 meter, let's say, precision, so accuracy. So it can become quite challenging, and the deeper you go, the less precise you are, and probably the more the time you need to actually deploy it. And eventually redeploy it if need be.
Yeah, and if I can add something, it's also a story of transferring, because if you can put your effort on decreasing the installation tolerances, but you can also put your effort in considering these installation tolerances into your design. So you can also find a compromise between where you want to put the effort.
Exactly, some robustness and sensitivity.
Yeah, exactly.
Okay. And then next, more in a financial corner. I hope you will be able to answer that as well as technical experts. But I've several people asking what is the share of the cost of the mooring solution with respect to the total cost. I think this mainly applies to the capex, but maybe also to the opex. Do you know what roughly is the share of the cost for this component?
Yeah. So typically it shouldn't be, let's say, the major cost driver of your plant. So typically it should range between a couple of percent to 10-15% tops in the most, let's say, challenging configuration. Obviously, we can also always find, let's say, very singular projects, but most of the time, yeah, should take into account a couple of cents per cents of euro per watt, typically, to 10-15 cents per watt. So, but yeah, it's very site specific. So I'm sure you understand that it's quite hard to tell, let's say, on the top of my head. But yeah, the anchoring and mooring cost won't be the major cost driver of your system. But you still need to focus on this because this is the reliability of your plant in terms of, let's say, survivability directly depends on that system. So it's still one of the key focus points. And it's also something that's easily, let's say, that you can optimize easily. You just need to have proper site data, and then you need to have a proper solution, innovative solution for on some location to actually have a cost-efficient solution.
Okay. There's you haven't really shared examples of this, but I'm wondering, have you also done projects in like extreme conditions in terms of temperature? So there's a couple of people asking, like for really freezing temperature winter conditions. How does it work there? What are the challenges for installing the mooring? Mm-hmm. Have you done such projects?
Yes. So that's quite some. Yeah, please.
No, but just, yeah, we have experienced some a project where we have snow load. For instance, you have snow on the top of the panel, so you have to. But when you go to this kind of area, you consider it in your design. You consider the amount of load you will the weight of the snow loading on the plant, and you also try to consider the frequency of the when it will be frozen. But definitely this is something very specific to the very site specific. And yes, we have experienced some site like this with snow, and it can be a challenge. And I think in the future this will be a big challenge to consider all these kind of issues, and especially for the structure, but also for the mooring, because if you have a mooring line which is stuck in the snow, definitely you have to consider it in the strength capacity.
But yeah, on top of that, maybe some market considerations. So this will be critical, notably in Europe on dams, because so there's a strong, let's say, market pull on dam. But yeah, snow loads is a real challenge for floatability. So you need to take that into account in your design of your system. The tilt is also different, obviously. So then the wind loads will be different. A large tilt enables the snow to actually fall. And the icing issue still need to be investigated, let's say, from an operational point of view. But from a construction point of view challenge, this is a strong challenge for operability, actually. So you will have an additional weather downtime because the lake is frozen, for instance.
Okay, thanks for sharing your perspective on that as well. Then there's another question coming in. You showed on the slide some examples about this as well. Some experience after 5 years of having the plant. This attendee is asking, how often should the fiber ropes, the mooring lines, be replaced? Is this something you can, because you had some fatigue in the materials after 5 years, is that already to the point where you have to do replacements, or?
I do not want to say this to all the question, but this is always site specific. It can go from 8 years to, I don't know, you can say, okay, my fiber rope will last during the 25 years. For this, we need a big feedback after maybe several years in the market. We will know. We can give a better answer, but I cannot say. I cannot give an average value for all the projects, because it depends on the temperature, it depends on the UV exposure, it depends on the waves you have. But definitely this is something you consider in your design and you take into account, and you can add some safety factor on your lines, on the capacity of the line you choose, and then it's considered.
Yeah, as much as possible, we need to avoid the placement of all the lines, obviously. So there's space, to be honest, for, let's say, co-development with fiber ropes providers, directly, to let's say, enable floating solar specific solutions. So this is also a way we're going down. Yeah.
Okay. Then I would like to, well, unfortunately, move on to the last question already, since I see time is running fast. We have way more questions that we cannot answer today, but luckily, as you can see on the screen as well, the contact details are available for all the teams. So for additional questions, please reach out. But to cover one last question, there's been a lot of, maybe hype or potential about this. When it comes to reducing water evaporation in the lakes. For certain regions, this can be a very interesting benefit. What is your take on that? Can floating solar reduce water evaporation, and also to what degree? Have you experienced this already?
I think I'm not so sure I catch the question. Maybe it depends on the recovery of the solar plant, but maybe Felix, you have a better input on that.
Yeah, so this is one of the key topics. It depends a lot on the location. It's similar to, let's say, the cooling effect. It actually depends on air temperature, water temperature, configuration, also with the panels. So it's really site specific. But for sure, floating solar can help reducing the evaporation rate. The question is how much, and I think we need to focus on putting some R&D efforts towards that regard. So on our side, we're part of a project that will look at that topic in particular. So this is one of the issue, but it's really specific to the technology and to the site. So it's hard to just conclude on that.
So for many questions, the answer is it depends on the situation, of course. So what we learned today is that floating PV and mooring is in any case complex. Well, thanks Pierre-André, and thanks Felix for sharing all your knowledge and your wisdom on floating and mooring today. Yeah, we will now go to wrap up the webinar almost. I would like to conclude with the fact that we of course have a lot of interesting events coming up in different regions, also on different topics, like our Solar Market Paris Spain, also our Greek event, Solar Asset Management Europe, and of course the Floating Solar Conference. There's a slight mistake here I see, because it's running both on 3 and 4 November, so for 2 days, and it will be a virtual event. Yeah, so thank you very much for joining us today, and I hope to see you again, of course, or many of you during the virtual conference. If you are planning to register, make sure to use the discount code available for webinar attendees, and make sure to use it before tomorrow night, because then it will expire. Thanks again for joining us today, also to the speakers, and wishing you a very good rest of the day.
Okay, thank you very much, everybody. Yeah.
Bye for now.
Bye-bye.
Bye, guys. Thanks a lot.
Bye.